The next learning objective talks about another type of biological chemical reaction, a biochemical reaction, a chemical reaction that happens in biological systems that is related to energy as well. This is oxidation. Oxidation of organic compounds plays an important role in metabolism. Oxidation of organic compounds means to have more bonds between carbon and oxygen. So if we have a carbon compound, then increasing the number of bonds to oxygen to those of those carbon atoms to bonds to oxygen is oxidation. And this is a really important point here. In an atmosphere with oxygen, molecular oxygen, oxidation is favorable. That is, it releases energy and it is spontaneous. An example of an oxidation reaction is shown here on slide 10. We have an organic molecule, methane, and we have oxygen from the environment. Oxygen gas, there's two molecules of oxygen here, can react with the methane and we'll get carbon dioxide. Now the carbon is, instead of being bonded to hydrogens, it's bonded to carbons. The hydrogens now combine with some of the oxygens and we get water, and we also get energy as an output. This reaction, this kind of oxidation is also called combustion, and I bet that you use this reaction today because methane is natural gas, and you probably burn some natural gas in a water heater in order to take a shower, or if it's during winter time, you probably use some natural gas in a furnace to keep your house warm. And what was going on was that natural gas, the methane in it, was oxidizing, combusting, combining with oxygen to make carbon dioxide and water and to release energy that you use to heat the water or the air in your house. The oxidation means that the carbon has more bonds to oxygen. Here carbon has no bonds to oxygen, 0. Here carbon has 2 bonds to this oxygen and 2 bonds to that oxygen, so a total of 4 bonds to oxygen, and that means that it's become oxidized. Oxidation doesn't have to be complete combustion to release energy, though. This is the complete combustion of glucose here. So glucose is an organic molecule that we've seen before. It has 6 carbons and 6 oxygens and 12 hydrogens, and it's shown here. And if we count the number of bonds between carbons and oxygens, we see that there are 7 bonds between a carbon atom and an oxygen atom. If we completely combust it, we get it all the way to carbon dioxide, and there are nothing but carbon-oxygen bonds. There are no bonds to anything else, no carbon-carbon bonds, no carbon-hydrogen bonds. That's complete oxidation or combustion. What's shown here below is partial oxidation, meaning that we increase the number of bonds between carbon and oxygen, but we don't combust it all the way to carbon dioxide. Glucose can be combusted partly, or oxidized, not combusted partly, it's partially oxidized to a compound called pyruvate or pyruvic acid. Pyruvate has fewer carbons because there are only 3 carbons in it, so we get 2 pyruvates per glucose, but it has more bonds between carbon atoms and oxygen atoms. These dotted lines mean that that's like 1.5 bonds. That's a chemical aspect called resonance that we won't worry about, but you can think of it as a double bond to one of the oxygens and a single bond to the other, or 1.5 bonds to each. So that's 1.5 plus 1.5, that's 3, 4, 5. This is a double bond between an oxygen and a carbon. So 5 bonds between carbon and oxygen in each of the 2 pyruvate molecules. That's a total of 10 bonds to oxygen. We went from 7 to 10. Now we are more oxidized, and this reaction gives up energy. We can use it to harvest energy.